We can have a little clap for Professor Well, thank you very much for inviting me, and I'd like to say something about what's happening in the Arctic at the moment, and why it's happening, and why it is a really serious threat to our future. That it's really a sign of climate change accelerating in a dangerous way, as if it wasn't already, but this is a bigger sign. I'll talk about some of the ways in which what's happening in the Arctic, why it's happening. We know that this is a famous curve. It's called the hockey stick curve, and it's been viciously attacked by anti-climate change people because they reckon if they can show this is not true, then they can show that climate change isn't happening. But what it is a curve of the average temperature of the Earth over the last 1,000 years. And of course, we haven't had thermometers for 1,000 years, but we've had, there's other ways of measuring temperature with ice cores and tree rings, and it's been possible to reconstruct the climate back to 1000 AD when we had the Vikings in Greenland, so it was quite warm. And it's been gradually getting slowly cooler until about 1850, and then suddenly it took off. And that coincided with the Industrial Revolution, and what happened was that we started burning fossil fuel, burning coal especially, and that produced the greenhouse effect started, and the climate rapidly got warmer. So people who say, well, climate change is just natural, they don't believe this graph, because the natural variations in climate are these little bumps and valleys here, which have happened for the last 1,000 years. We were heading very slowly towards a new ice age, which we would have reached in maybe another 10,000 or 20,000 years, but we stopped that when we made ourselves warmer. But this is such a rapid change that it can't possibly be a natural fluctuation. So, okay, well, it's happened all over. This warming has happened in the last 150 years. It's happened over every part of the planet. Wherever you look, wherever you do your measurements, you find this accelerating warming. But it's faster in the Arctic. So that trend that I showed, this is the Arctic from 60 to 90 north. It's the same trend, but you can see that the temperature difference, the warming that happened over the world as a whole has been about 1 degree, but the warming that's happened in the Arctic, as on the left, is 2 degrees. So the Arctic has been warming about twice as fast as the rest of the world. It's for various reasons, but it's there's an amplification of warming in the Arctic. I might be better off without this. It seems so it's working random. Okay, here we are. Now, if the Intergovernmental Panel on Climate Change, which has climate models that predict what's going to happen as a result of all this, predict that this Arctic warming will continue, and that the warming of the planet over the next 100 years will take us to a state where, in about 100 years' time, that most of the planet will have warmed by about 4 degrees, which is bad enough, but the Arctic will have warmed by more than 8 degrees. That's the darker colouring here is increased warming in the Arctic. So we know that increased Arctic warming is set to continue, and also we know that warming is associated with increased carbon dioxide content in the atmosphere. When you add carbon dioxide through burning fossil fuels, it absorbs some of the outgoing heat radiation, and the planet has to warm up in order to restore balance. And this has happened many times in the past with the ice ages, where you have this kind of pattern of very cold ice age conditions, which were about 8 or 10 degrees colder than now. Like about the depths of the last ice age were about 8 or 10 degrees colder than they are now, and also had about 100 parts per million lower carbon dioxide. So the increased carbon dioxide is associated with increased temperatures, and vice versa. And this is what we've been doing to the world's sort of carbon dioxide in the atmosphere. We've been taking it way beyond anything that it ever reached naturally. That natural variation between the ice age and the present was about 180 to 280. But we're now gone up from 280, which we were at in the 19th century, and we've gone shooting up now to 400. So this is a change which is greater than any change that's happened naturally over the past several million years. We've never had that much carbon dioxide in the atmosphere through any natural climate change effect. We're doing an experiment on the atmosphere which transcends anything that nature's ever done. So unknowingly, we're just doing it. And this is rather frightening. Also, methane levels in the atmosphere have gone up as well. This was the methane level again up until the Industrial Revolution, and then it shot up and gone up to about 3 times the level it was at before the Industrial Revolution. And this is nitrous oxide, which is another greenhouse gas that's gone shooting up. So we're really, this is really a big thing that we're doing to the atmosphere. And the thing that's doing most at the moment is carbon dioxide. This is relative forcing, that's the amount of heating that is being done by different types of pollutants in the atmosphere. Carbon dioxide is the worst, but methane is following along behind, about a third to a quarter of the CO2 effect, and then there's a lot of smaller factors which are pluses and minuses, but the two big positives are carbon dioxide and methane. You hear politicians spouting a lot about how we have a plan in place to reduce Britain's and the world's greenhouse gas emissions by N% by some date in the future that's safely beyond the present Parliament. So it's something like 20% by 2030 or 30% by 2050. Some formula like this. But if you look at what's happening now, nothing's happening now. And in fact, things are getting worse rather fast. If we look at, this is 2010 compared to 2009, it's the last year for which we've got really good figures. And every nation except Russia has increased its carbon dioxide emissions, and by these percentages: 4% in the US, 9% in China, 9% in India, 6% in the UK. Russia claims to have decreased it, but because you don't really ever believe Russian statistics. The world has gone up by 6%, and that's in 1 year. The amount of carbon dioxide level in the atmosphere went up by 6%. And that shows how much we've been doing about our emissions of greenhouse gases. That is nothing, or less than nothing, because they're increasing faster than exponentially. They're increasing faster than they were 10 or 20 years ago. So that's really worrying. So let's look at some of the predictions that you get from that. Firstly, are that there will be drying of the most sensitive places on Earth, the ones where subsistence agriculture exists. So the red here shows places that are going to get drier as a result of global warming, and the blue is where things are going to get wetter. So up here in the northern hemisphere, things are going to get wetter. We're going to have an increase in precipitation of maybe more than 20%. But the drying is where it's going to get drier by more than places like Sub-Saharan Africa, Central America, the Amazon rainforest is going to dry up. So even if we don't cut it down, it will dry up. And the Southern Africa, and as well as Northern Africa, and the Far East, places where you really need rainfall for subsistence agriculture are going to not get it. So there's going to be a food crisis coming along because of the changes in rainfall patterns because of global warming. So that's just another facet of what's going on. So that's the planet, which is in a bad way. But if we now look at the Arctic retreat, this thinning of the sea ice, is something that we've been measuring for a long time. So people who've been actually working in the Arctic knew this was coming. So the surprise has been that various scientists have said this is very surprising, this sudden disappearance. It's mainly scientists who haven't actually been working in the Arctic, because people who have been measuring this disappearance for many years. Here, for instance, is the Arctic ice extent in summer. That's one down here, and it started to retreat in 1950, as far as we can see. It was difficult to make measurements then because we didn't have satellites, but with aircraft and so on, it was possible to see the Arctic sea ice, summer sea ice, declining from 1950 onwards. And then, it accelerated, and the famous year, so up until this year, was 2007, which is the one on the left here, where the pink line here shows the average ice extent in summer. In the winter, the Arctic is completely ice covered, and the sea ice goes right around a lot of the subarctic regions, North Atlantic and the Bering Sea. But in summer, it used to just retreat, so it still filled the Arctic Ocean. So the pink line was the boundary. Now suddenly there's a huge great bite being taken out of that, and you can see that the area is only about half of what it used to be in the typical summer. You now have an ocean here, half an ocean anyway, whereas previously you would still have ice. So that was a big change, and 2007 was reckoned was a sort of famous year, but we thought that, but the people who thought, well, we shouldn't worry too much about it, were saying, well, it's because there's an unusual wind direction that's blowing ice out of the Arctic and blowing it down into the Atlantic. And that was the case, because you could see from the tracks of drifting buoys. But then it happened again in 2010. It hovered about the same value, but it was more evenly spread. The retreat was all around the Arctic. And then we came to this year, and this year is the worst yet. Again, the yellow line was the average, and then this is what we got in mid-September, a week ago. And there's this huge gap, hole again, but there's also all around the edge, it's retreating everywhere. It hasn't just retreated in the middle. And when we look at straight down on the North Pole, we can see this huge expanse of open water all the way around the Arctic. Britain is down here, Spitsbergen and Greenland, but the ice extends right from the several islands here, right across just across to Greenland, but that's all there is that's left this year. Okay, and the thickness is very low as well, and this is the thickness in meters, and the blue is just 1 meter. So what's left is very thin, and you can see that in the next year this lot's going to go as well. So you will only have this very small fringe around the north of Greenland and Ellis New Island. That's about 4 meters. So the idea that the ice, because it's retreating and thinning at the same time as retreating, is going to go very soon, in about the next 3 years, is really based on observations and measurements. It's not a sort of crazy alarmist idea. Peter Lilly described me as a well-known alarmist on TV, so, but it's basically it's scientific measurements, but I guess he doesn't know well. And anyway, here we are. This is us now. The red is the area of sea ice in summer, and this is the decline over the last 20 years, 30 years since the 1950s, and all these other curves are the predictions of climate models of the Intergovernmental Panel on Climate Change, which are obviously wrong. They're all very complacent because the black line, which is the average prediction of these climate models, shows the area just declining slowly, and there's still plenty of ice around by 2100. But the reality is it's been declining really precipitously, and here it is this year, and you can see that if it carries on at this rate, it'll be gone well before 2100, in fact more like 2016, I think is at this rate, that's how long it'll last. This shows this year, what's happened this year, the blue line, and the black line is what happens in an average year, a decline to a minimum in the summer, then it grows back again. But the minimum, instead of being up here, is down here now. And there's a few other years. Well, how do we know why this is happening? I mean, the reason that I think it's happening is because the ice is getting thinner. It's because of the warmer climate means that less ice grows in the winter and more ice melts in the summer. So if you have less growth in the winter and more melt in the summer, eventually the melt will catch up with the growth and it'll all just collapse. And that's what is basically happening this year. And we know how thick it's been because for the last 30 or 40 years I've been measuring the thickness from submarine voyages, which are extremely unpleasant things to do, but you have to really give credit to the Ministry of Defence here, because every time they send a submarine to the Arctic, they have scientists go on board and can measure the ice thickness as it crosses the Arctic with an upward-looking echo sounder. This has been a fantastic way of tracking the thinning of the ice, so it's been a real service to climate research. So this was the last one I was on, and this shows the surface in the ice and the echo sounders and this dome here. And we went across, first started from Faslane, and went across the whole Arctic to the Beaufort Sea on the other side. So we were able to do a complete cross-section, and that's very typical of a submarine voyage. You don't cover the entire Arctic, but you do a slice across it, which is really can show you what's going on. And then these are some previous voyages that the British submarines have done. So so the Ministry of Defence has been really helpful to science there. Well, the trouble is we don't have many submarines, and in the absence of us having a submarine all the time, you have to do it in a more painful way, using autonomous vehicles which don't have people in them. They're programmed, they run under the ice, you program them to measure the ice thickness and come back again. So you can get very nice pictures of the other side of the ice, but it's a lot of hard work. A submarine is, apart from when it has an accident like you did last time, the submarine is quite comfortable, but working with AUVs is quite painful. I'm just showing this to show that the suffering involved in Arctic research, because when we say the ice is thinning and disappearing, and this gets poo-pooed by climate change deniers and sometimes by Met officers, it's as if we haven't actually been killing ourselves to get the data, but we have. And first of all, you kill yourself on the submarine, but then you kill yourself doing this kind of work, because you have to set up a camp on the ice, and then you use these vehicles which you put so this is a tale, typical woes of a polar researcher. You have to set your own camp up and build it, and then you have a hole in the floor, and then you live in this tent for about a month, and then you get this beautiful data, which is what tells you that the ice is still thinning. This shows the underside of the ice with what are called pressure ridges, which is where the ice is pushed together to make a thicker piece. But those pressure ridges are disappearing. There's not so many as there used to be. So this is not a good picture, but it's taken from the vehicle with a video up at the bottom of the ice. So that's the sort of thing we do to get this data. And we were starting to see this thinning as early as 1990. This is 1976, 1987, and 2004. And these are depth thickness contours. You can see it was about north of Greenland, for instance, was about 6 metres of ice in 1976, 4 metres in 1987, and about 2 metres in 2004. So it's a big decrease going on. So when we look at the thinning combined with the shrinking and multiply the two together, the volume of the ice that remains in the summer is really shows a huge decrease. And it's down now to about 30% of what it used to be in the 1980s. So in the summer in the Arctic now, you only have 30% as much ice as you used to have. This is living memory, but in fact, I was quite old then, so it really is a big change. It's not a small fluctuation. It's a big loss. And these are the trends this is what leads you to the prediction that 2015 is when it would go. This is the month of August and September. These are the areas that are left of ice at the left. You can see that the retreat is accelerating, and if you just extrapolate that down to 0, it happens about 2015. And these are other months of the year, and they show that the Arctic, the ice-free period will expand. It will start off as just being a month, and then it will grow until it's a longer summer period. But it's looking like about 2015 or 2016. The old ice, what will survive the longest is the oldest ice, which is called multi-year ice. The Arctic used to be full of this old ice. That's the red stuff on this satellite map. But it's been shrinking back, and that earlier picture I showed there was just a little fringe of it left. This was 2008. So it can't really hold the fort very well. There's not much of it left. So that's what's been happening. And other things that are going on are that global sea level is rising, and it looks like it's beginning to accelerate a bit. And the reason for that is that the Greenland ice sheet, which is on land, solid, about 2 miles thick, has started to melt at the surface. It used to not melt at all, even in the summer. But now the atmosphere is warmer over Greenland. Because of all the sea ice retreating, you have warmer water around Greenland instead of ice in the summer. And that brings warmer air over Greenland. And you're now getting some surface melt of the Greenland ice sheet. And that melt runs off into the ocean and increases sea level. So it's speeded up the rate of rise of sea level. And the predictions for what will happen this century were that we might have about 60 centimetres of sea level rise just due to warming of the ocean. But if you add in the accelerating Greenland ice sheet loss, it could easily get beyond a metre or even up to maybe 2 metres, and which doesn't sound a lot, but it would really increase the frequency of catastrophic flooding events, especially in poor countries. And the worst case is Bangladesh, for instance, because if you have a metre of sea level rise and you have a country where about 20 million people live within a metre or 2 then you're going to have flooding, and you already do have floods because of storm surges in the Bay of Bengal, but they'll become much more frequent. And there's no way of building flood defences because the country's too poor, and there's nowhere for the people to go because there's more people living behind the people that are nearest the coast. So this rise in sea level, accelerated by the melt of the Greenland ice sheet, could be really disastrous for places like Bangladesh, eastern coast of China. Of course, not nice for us either, but we can at least build flood defences. And that's the consequence of the indirect consequence of the sea ice retreat.
You come a bit closer.
Right. Another consequence, which is nasty, well, there's two other consequences. One is that you're replacing this white surface by dark seawater, dark water. And a white surface absorbs about 70% of the radiation that falls on it, whereas seawater absorbs less than 10%. And so, reflects that 70%, stuff like that. And so there's a decrease in the average albedo level of the planet. That's the percentage of radiation that's reflected straight back into space. And that in itself accelerates global warming. But on top of that, it's the fact that the retreat so far has been into the centre of the Arctic. So what's left of the sea ice sits in the middle of the Arctic Ocean here, where there's very deep water, 4,000 or 5,000 metres. But where the ice has disappeared from is all round the edges, and the Arctic has these huge continental shelves that are only about 100 metres deep. So these are very shallow, and there's a deep bit in the middle. But the ice has retreated off the shallow bits, and the shallow water can warm up if the ice retreats from it. Deep water, it doesn't warm up. It's really stable, but shallow water does. And it's just a computer view that shows the contrast between the shelves, which are so shallow, and deep water. But these shells are so shallow that the water on them warms up during the summer when the ice retreats off it. And on the seabed here you have permafrost. That's frozen sediments left over from the last ice age, because on land in the northern, in the Arctic, you have permafrost on land, which is that below the very top surface of the soil you have several metres or tens of metres where the soil is completely frozen. You have lenses of ice, it's called permafrost, and that extends out to sea. But as soon as you start warming the ocean, that permafrost starts to melt. And what we're seeing now is the offshore permafrost melting, and there's a Russian expedition just coming back, in which that's they're seeing big plumes of methane being emitted, but the permafrost is trapping methane and in the form of methane hydrates. And as soon as the permafrost melts, the methane is released. So we're getting a methane kind of disaster happening and developing in the Arctic, where all these offshore regions are emitting methane plumes, and methane levels in the atmosphere are going up as a result. We can see this warming, for instance, the temperatures sort of around the edges of the Arctic this summer were getting up to 6 degrees, 7 degrees, 8 degrees. That's quite warm. It's like the North Sea in winter. And this is the measurements of methane levels in the atmosphere. This was earlier this year in the winter. But the big increase has been in the Arctic. And people who measure methane say, and they map it partly from sampling stations and partly from satellite sensors like this one. And they say that the rise is concentrated in the Arctic. So it's these methane plumes coming off from the seabed that are increasing methane levels in the atmosphere. And methane is a very powerful greenhouse gas. So that's another factor causing climate change to accelerate as a result of the sea ice retreats. This is where this expedition's been working, in this very shallow water of, in the East Siberian Sea, and these are places where they've been seeing methane. And they're only just back from this year's expedition, so we don't know what they've got. So anyway, that's been the retreat. Because contrast this, some people are happy about this. One is the oil industry, because it makes it easier to drill offshore. And the reason is that when drilling started in the Arctic, it was done in very shallow water with drilling rigs mounted on the seabed, so that's relatively safe. But now the search is extended into deeper water, so where you have to use a drill ship, which is dynamically positioned, so it stays in one place. But it can only stay in that place and drill if the ice around it is broken up. So what you have is a drill ship sitting there and icebreakers continually circling that ship, breaking the ice up so that there isn't any forces that are strong enough to push the drill ship off. So you can only do that if the ice is thin enough to be easily broken by icebreakers. So you can only work in the summer anyway, and you can only work in the summer with thin ice. So this means that conditions are much more favourable for offshore drilling than in the past. And so there is a sort of Arctic oil rush going on. Most of the sites are in the Beaufort Sea and Baffin Bay, sort of on the American side of the Arctic, but there is a big area of continental shelf off northeast Greenland up here, which has been leased by Shell and various other companies. They've taken the whole of the shelf here, and you can see that if there were an accident here and oil were released, then the oil will come down this current, the East Greenland current, down the coast of Greenland, and if it was happening during the winter, then you'd have oiled ice coming down here and melting and being released down here around Iceland, quite not that far from Orkney and Shetland. So we're sort of in the firing line here, receiving oil from melted out ice, where that oil is spilled off northeast Greenland. So we have to. So recently there was a report by the Environmental Audit Committee of the House of Commons last week saying about protecting the Arctic, saying that we should hold back from drilling until we really find ways to be able to clean up spilled oil that's spilled under ice, which we don't really have such ways at the moment. So that's whether that will have any impact, I don't know. So that's the conclusions about the Arctic and global change. It is all kind of doom and gloom actually, because the retreat of the sea ice is something that is giving you this impact of albedo effect, which is accelerating global change. It's giving you this big methane releases, which also is accelerating global change, and it's having an impact on oil drilling and transport. But what can we do about it? The hope is that, hope always is that we can reduce our carbon emissions so that these trends are slowed down. But even if we reduce our carbon emissions to zero, it won't really bring back the Arctic sea ice, because the Arctic sea ice it's already retreated off the continental shelves, so permafrost is already melting. We have to cool the climate to bring Arctic sea ice back. We can't just let it warm more slowly, because it's already warmed to the point where it's got rid of the summer sea ice. So we have to actually cool it, and to cool the climate is really difficult, because you actually have to reduce CO2 levels, which means you have to get rid of CO2, or you have to try and find some other technical way of cutting back on climate change. And these are all these various geoengineering techniques that have been proposed, where you whiten clouds by putting water vapour into them, or you spread particles in the upper atmosphere to reflect solar radiation. And these sound a bit, when most people thought these things are kind of frightening, you don't want to do them because we've messed up the climate enough with technology. We try something else with technology, it will probably make things worse if you want. That's a cynical view of technology. But whether it might do that, and there hasn't been enough research on any of these techniques to be sure that it won't. But I think we do need to go urgently for research into these possible techniques, because we can't depend on reducing carbon dioxide emissions. Firstly, because we're not doing it anyway, and secondly, because even if we did, it wouldn't save the Arctic sea ice. So if we want to try and bring that sea ice back and insulate the Arctic so it's not emitting methane, then we have to go for something that has a bigger effect and an immediate effect. And so that does mean thinking about geoengineering methods and trying to find one that will work and that will target the Arctic as opposed to acting in a diffuse way over the whole planet, something that hit the Arctic. So those are things we should be trying, but we should also, of course, be reducing carbon emissions and going for renewable sources of energy pretty urgently as well. Yes?
We'd like to take some questions now for Professor Warren. So, hands. Cheryl.
I know that generally scientists don't like to link specific weather events with climate change. Has the reduction in Arctic sea ice impacted the Gulf Stream, which led to the weather we saw this summer, in your opinion?
Well, that has been taken seriously, yeah, because something that scientists shy away from. The question was, is the weather events of this year in Britain and in the US related to Arctic sea ice retreat? And that has been seriously put forward. Normally, scientists don't like, when something like that happens, they say, well, you mustn't confuse weather with climate, because climate scientists are always getting